Hi, Assalamualaikum. Welcome back to my channel, Physics from 5 KSSM. Today we continue Chapter 7, Quantum Physics, on Topic 7.2, Photoelectric Effect. In this video, I will discuss two learning standards. The first one, explain photoelectric effect. The second one, identify four characteristics of photoelectric effect that cannot be explained using wave theory. What is the meaning of photoelectric effect? We have discussed earlier about energy of photons. Energy of photons is absorbed by electrons. When light is shined onto a metal surface. When a metal surface is illuminated by beam of light certain frequency, electrons can be emitted from the metal. So this phenomenon is known as photoelectric effect. The video here shows one activity of photoelectric effect. So in this experiment, using a metal plate rubbed with iron warp to remove the outside part of the metal plate. Now place the metal plates on the plate of the gold leaf electroscope. In this activity, we use two sources of light, visible light and UV light. First of all, we need to charge the electroscope to negatively charge by using the rod or polythene rod. Firstly, neutralize the metal plate and then charge again with the polythene rod. So the electroscope will become negatively charged. Look at again the activity. Bring the rod near to the plate and then touch it to earth it and then remove the rod. Now the electroscope is negatively charged. Shine the plate with visible light. What happens to the gold leaf? The gold leaf does not fall, showing that there's no discharge process or no photoelectric effect occur. Let's shine by using UV light. Once UV is shined onto the metal plate, you can see the gold leaf fall, showing that there is a discharge of electrons by process of photoelectric effects. So from this activity, we can see the UV light can produce photoelectric effect, but the visible light cannot. Means, for the process of photoelectric effect, it requires a certain frequency of light. Even though increase the intensity of the visible light, it still cannot increase or cannot produce photoelectric effect. But if shine with a UV light at certain frequency, it able to produce photoelectric effect even though at low intensity. So we can see photoelectric effect depends on the frequency, not the intensity of light. This is a circuit that shows the photoelectric effect. Consists of cathode, which is a light-sensitive metal, and anode, which is connect to positive terminal of battery, and cathode connect to negative terminal of battery. And there is a milliammeter to detect current or to measure current. Let's look at one by one. Number one, when a light-sensitive metal surface or cathode is illuminated with a certain light beam, electrons will be emitted from the metal surface. These electrons are called photoelectrons. The emitted photoelectrons are attracted to the anode, which has positive potential. So you can see electrons that are emitted when moved to the anode, it means the circuit will be completed and current will flow in the circuit. The movement of the photoelectrons from the cathode to the anode produce current inside the circuit. The milliammeter shows the value of the current. This circuit shows how intensity affects the value of current flow in the circuit. The highest intensity of light will cause more photoelectrons to be emitted and attracted to anode. Thus, high current flow in the circuit. Low intensity will cause small amount of photoelectrons emitted and smaller current flow in the circuit. Okay, last time we have discussed about energy of photon, E equals to hf and de Broglie wavelength lambda equals to h divided by p, which involve Planck constant h. How can this value constant h be determined in the lab? You can refer to activity 7.5 in your textbook. Aim of this experiment is to determine the value of Planck constant using Planck constant kit. Apparatus required: Planck constant kit, which consists of 9-volt battery, 1 kilowatt potentiometer, LEDs of different colors, and milliammeter and voltmeter. Okay, let's watch this video how the experiment is carried out. So you can look at the circuit here. First, the positive terminal of power supply connected to milliammeter and negative terminal of milliammeter connect to one end of a resistor. Negative terminal of power supply connect to one end of LED. Now, connect the potentiometer across LED. On the power supply, set the voltage to 0.5 volt. So you can see the reading of milliammeter is still 0. 1 volt, still no readings at the milliammeter. Increase the voltage to 1.5 volt. We can see the reading of the milliammeter start to increase. Increase to 2 volt. So you can see the reading of milliammeter increase until you increase the voltage to 3 volt. The value of current increases more. Increase to 5 volt. So you can see increase to the highest value of current. So means you have recorded the value of voltage V and also the value of current recorded by ammeter. Then you can plot a graph of I against V. Just now, from 0 to 1.5, about 1.5 volt, the reading of milliammeter is equals to 0. And then at point 1.5, about 1.5 volt, the current start to increase. Okay, you draw a line, then you can see when extend, it will intercept at one point at voltage axis. That value, we call it turn-on voltage. For the LED, the one that we start with the red color just now, the turn-on voltage is 1.65 volt. Meaning starting from that point, the current start to increase. Yellow color, 1.85 volt. Green color, 2.00 volt. Violet, 2.75 volt. The value of wavelength, we can check the wavelength of the colors. Then calculate for 1 over lambda. Okay, now we have set of data for turn-on voltage and 1 over lambda. Plot a graph of turn-on voltage against 1 over lambda. The graph of turn-on voltage against 1 over lambda shows relationship which is increases linearly. And we calculate the slope or the gradient of the graph. We can calculate the Planck constant as gradient multiply E divided by C, where E is charge of 1 electron, C is speed of light. From this experiment, the value of H calculated is equals to 6.9 times 10 to the power of negative 34 joule second. Theory value is 6.63 times 10 to the power of negative 54 joule second. Means there is a little bit of error from the values determined through experiment. Let's try using the procedure stated in your textbook to carry out the same experiment. So you can see the setup of the circuit. The procedure number 1, using the red LED, connect the Planck constant kit, adjust knob on the potential to obtain the potentiometer to obtain the voltage V 0.2 volt, record the milliammeter reading. Repeat step 3 for V equals to 0.4 volt, 0.6 volt, 0.8 volt until 3.0 volt. So what we have recorded actually is the value of voltage and current. Plot a graph of I against V. Draw a line, find intercept at V-axis, which is turn on voltage. Repeat the same step for different color of light: white, red, orange, green, and blue. For each of the color with certain wavelength, calculate the reciprocal of wavelength 1 over lambda. For each of the color has its own activation voltage. So you can check from the graph. The turn on voltage for the blue color is about 2.5 volt. For green color is 2.00 volt, for orange color 1.90 volt, for red color 1.78 volt, and for white color is 1.35 volt. From the value of 1 over lambda, the reciprocal of wavelength calculated, and the value of activation voltage, we can plot a graph of turn on voltage against 1 over lambda. Based on the graph plotted, determine gradient m of the graph and calculate Planck constant h, given the formula h equals to me divided by c. The value of E also given and the value of C also given. Calculate the gradient from the graph, from the triangle drawn on the graph. So you get the value of gradient equals to 1.91 times 10 to the power of -6 voltmeter. Using the formula given, H equals to ME divided by C, substitute the value of gradient, the value of E, and the value of C. So we get the value of H from this experiment is 6.35 times 10 to the power of -34 joule. Compared to the theory value, 6.64 times 10 to the power of -34 joule second. Discussion: what is the relationship between activation voltage and LED light wavelength? Activation voltage VA is increases linearly with 1 over lambda. The longer the wavelength, the smaller the activation voltage. Let's look at again the characteristic of photoelectric effect, the one that discussed by classical theory, and then the result of the photoelectric effect experiment. Photoelectric effect occurs when light strikes the surface of metal. Electrons in the metal absorb energy from the light and escape from the metal surface. According to classical theory, light is waveform, is a spectrum with continuous energy. Photoelectric effect should be able to occur at any light wave frequency. Bright light, which has high energy, should be able to emit electrons quickly. Dim light has low energy, so electrons need a longer time to absorb enough energy to escape from the metal surface. However, the results of the photoelectric effect experiment show that the emission of photoelectrons only apply to light wave with frequencies that exceed a certain value without being affected by intensity of light. Means the occurrence of the photoelectric effect just depends on the frequency, not the intensity of light. Photoelectrons are also emitted instantaneously of those light frequencies at low light intensities. Let's look at the 4 characteristics of the photoelectric effect that discussed by quantum theory. The higher the frequency of photon of light, the higher the kinetic energy of photoelectrons emitted from the metal surface. Means kinetic energy depends on frequency. The minimum frequency of light needed for a metal to emit electrons is known as threshold frequency for the metal. Means the frequency of light must at least equals to threshold frequency of the metal. The kinetic energy of photoelectrons does not depend on the intensity of light. An increase in light intensity does not produce photoelectrons with higher kinetic energy, but produce more number of photoelectrons emitted. Photoelectrons are emitted instantaneously when metal surface is illuminated by light. As comparison, we can look at thermionic emission. The emission of electrons from metal surface by thermionic emission may take some time. So as compared to the photoelectric effect, thermionic emission takes longer time for electrons to be emitted. When metal surface is illuminated with light, the emission of electrons from metal surface by photoelectric effect is instantaneous. Means once the light is shone on the metal surface, automatically electrons will be emitted. The threshold frequency, FO, is the minimum frequency required to produce photoelectric effects on metal. Formative practice 7.2. Number 1. What is meant by photoelectric effect? Emission of electrons from a metal surface when shone on by light of a certain frequency. Will a bright light emit more photoelectrons from a metal surface compared to a dim light of the same frequency? Yes, the number of photoelectrons emitted depends on number of photons that arrive on the metal surface, means the intensity of light. State 4 characteristics of photoelectric effect that are obtained experimentally. The higher the frequency of light photons, the higher the kinetic energy of photoelectrons emitted from the metal surface. Means the kinetic energy of photoelectrons depends on frequency of light photons. The minimum frequency of light needed for the metal to emit electrons is the threshold frequency of the metal. The kinetic energy of photoelectrons does not depend on intensity of light. Photoelectrons are emitted instantaneously when shone on by light. So these are the 4 characteristics of photoelectric effect that are obtained experimentally. Number 4. Why are photoelectrons emitted instantaneously from metal surface when it is illuminated by a light of certain frequency? Light consists of discrete energy packets. When a photon hits a metal surface, all its energy will be transferred to an electron in the metal. With this, photoelectron will be emitted instantaneously from the metal surface if the frequency of light is higher than the threshold frequency of metal. Number 5. Does an increase in light intensity increase kinetic energy of photoelectrons? Why? No, the intensity of light only affects the number of photons arriving on the metal per second, or photon rate. The maximum kinetic energy of photoelectron is influenced by the photon energy. Increasing the light intensity will not increase the kinetic energy of photoelectrons. It just increases the number of photoelectrons emitted due to intensity of light affects number of photons reached at the metal surface. That's all my video today. I will continue in my next video 7.3 Einstein photoelectric equation. Thank you for watching. Bye.